So how many people does it take to charge a capacitor bank? Evidently in solar it's quite a bit. Hello and welcome to the attic. I'm going to discuss pre-charging capacitors with a lamp and more importantly dim bulb testers. So this is a very popular subject on DIY forums. I guess everyone thinks they can just hook up a resistor. Sometimes a little tougher than that. I like using lamps, mainly because they're cheap. You know, you can go out and spend some expensive power resistors, or I've gotten these for like 99 cents for a pack of two, either 300 or 500 watt. The old standard bulbs aren't really available anymore, except in a discount bin. This one in particular is a 500 watt, and it's halogen. So halogen burn a little hotter and a little bit more efficient, but you know, doesn't matter. One thing nice about these is that the ends are a form of stainless steel, and they easily take solder. I mean, you would have a hard time finding a socket for this, and you'd be paying through the nose. You don't really need it. You can solder a wire on each end, put some heat shrink over it to protect it, and you don't use it that often. So, like, you know, $1 is all you should spend for pre-charging. So let's get into some testing. You know, the ohms of a bulb are, you know, if we know the voltage and the current, you can get the ohms. But most times we just know the voltage and the watts. And so you take the watts and divide it by the voltage, that'll give you the amps. Okay, we still know the voltage, so we put the amps in, that gives us the ohms. But a lamp is a positive temperature coefficient, and they have a range of well over 10 to 1 between a cold resistance and a hot resistance. So right now I have a standard 100 watt bulb here, and I'm operating that on 12 volts, and you see it's you know, 0.24 amps, so just about a quarter amp. If we waited long enough, it would warm up even more and drop more in resistance. You know, 100 watt bulb is not going to do much for charging because when it's hot, it's 144 ohms and drawing 0.83 amps. But at 12 volts, it draws 0.26 or a quarter, so it's around 45 ohms. And it's 9.5 ohms when it's cold. So a more reasonable thing for charging up like 48, 24 volt capacitor banks is using one of these 500 watters. These are about 2 ohms when they're cold. Interesting thing is I measured this one, and it's 3.7. And I've kept measuring it thinking that there's something wrong, but that's what it is. But, you know, nothing close tolerance, doesn't really matter. So if you use one of these, initially when you touch it, it'll be cold, and it'll draw about 25 amps on a 45 volt capacitor bank. And, you know, they make a little bit of zap, but, you know, you're just touching the leads, doesn't matter, it'll drop soon enough. And these, at 60 volts, are 14.8 ohms, so it's about 0.32 amp charge, so that's nice. So let's unscrew this one, and let's see what, see, at 12 volts, it'll actually glow. And you're at 1 1/4 amps. But now, if we unplug this and put it at 60 volts, and that's close to what you will have for a 48 volt battery bank, it's pretty bright. It's 2.93 amps. And the regular 100 watt light bulb is 0.6 amps. So This is plenty good enough for pre-charge, and if you are concerned about too high of a current, you can put 2 of these in series. Be perfectly fine. But what I really want to talk about is a dim bulb tester. It was 1965 when I first saw an ad for an ICO amplifier kit, and it said only test equipment you needed to test this amplifier kit was a lamp. And I've been using this ever since. Their theory is that if you're going to screw up building something, or solder bridge or something not soldered or backwards, if you have a lamp in series, that'll limit the current and you won't be continually blowing fuses. I have someone right now who's trying to repair a power supply, and it blew a 10 amp fuse, and I said, well, use a dim bulb tester to check and see if it's okay before you just throwing in another fuse and hitting it with 120 volts. They didn't do that, and immediately they blew another fuse, but more importantly, they also blew a trace on the circuit board, because after the first event, the diode bridge was fully shorted, and it was going to draw a lot more current the second time, and the first time had stressed the board a little bit maybe, but fuses are expensive now, and well, with a dim bulb tester, you can actually go in and measure things while it's on. So you're limiting the amount of current, and it's pretty easy to find a short. I mean, if you see a bridge rectifier and there's no voltage across it, that's a short. If you have an amplifier and one of the transistors has a low voltage across it, sometimes they're not shorted. Sometimes there's some problem with the bias to it, and it's just held on with a bias current or something like that. But it makes it a lot easier to diagnose. You're not blowing fuses all the time, which are expensive, and you're not doing any further damage. Really nice diagnostic tool. So yeah, if you have a 12 volt inverter and it's blown a fuse and you find 2 shorted FETs in it, well, you go out and buy some new ones and put those in, and the first thing you're going to want to do is plug that in and test it. Well, it may be that the driver is damaged, or there's something else that's damaged in the circuit, and it'll draw a lot of current, blow the fuse, possibly destroy the FETs you just put in. If you have 2 of these lamps in series, in parallel, that's a pretty low resistance, and you can test it as long as there's no load on it. And like when you're doing a pre-charge of a capacitor bank, you want to have your inverter off, because all you want to do is charge up those capacitors. But dim bulb testers, I have one with a power strip, and it has a light bulb socket to 2 AC pins, and so I have a power strip, and the first 3 or 4 sockets have the lamps in them, and those are all in parallel, and I can just screw in as many light bulbs as I want. I can start out with a 30 watt bulb and go to 100 and maybe 200s in parallel, and along with the 30, and you can adjust the amount of current. It's a neat little tester. The last socket is the one that you plug your device into. But I've been doing dim bulb testing, and I've been servicing things for a long time. It's just a hobby. I like things that are broken. It's a challenge. So that's it. If you look at some of these figures here, if you 100 watt 120 volt lamp, the DC resistance is 9.5 ohms, and at 12 volts you can see it goes up to 45 ohms. At 60 volts it's 102 ohms, and the calculated resistance at 120 volts is 144 ohms. That's a 15-to-1 ratio. And now with a 500 watt 120 volt lamp here, it's around 2 ohms, It goes up to close to 15 at 12 volts, and it's 29 ohms at full voltage. So remember your Ohm's law. It's easy to get the resistance, but you'll never really know the resistance, unless you put a current meter on it when it's operating, because you can't measure them hot. So thanks for watching. I hope you use this. It's very useful.